Assalamu alaikum students. Today we will discuss the details of forward finite differences. Okay, so we will let independent variable is x and dependent variable is what do you say, y is equal to the function of x. So our name of the dependent variable is y or the function of x. This is dependent variable. Okay, so first of all, we will define what do you say, number one is zeroth what do you say, forward finite difference. And this is written as delta 0 f of x, and zeroth forward finite difference means the function f of x will not change. Means it will come to be as it is. Means the answer will be f of x, means delta 0. Okay, so delta 0 will say nothing to the function and the function will not change. Okay, in other words, zeroth forward finite difference means x will not change. So that's why, because if x doesn't change, the function value or the value of y will not change. So it will come as it is. So this is the definition of zeroth forward finite difference. Okay. Similarly, as we have already done in the previous lecture, there is a first forward finite difference. First forward finite difference. Okay, and that is defined like this: delta 1 f of x, and this is what do you say, is written as f of x plus delta x and minus f of x. Okay, and if what do you say, if x is xi, in that case the first forward finite difference is written as delta 1 and f of xi is equal to f of xi plus delta x minus f of xi. Okay, and in terms of the name of the dependent variable y, we can write it like this: or delta 1 yi is equal to yi plus 1 minus yi. Okay, where what do you say here, yi is actually the value of the function at x is equal to xi, and yi plus 1 means the value of the function at xi plus delta x. Okay, so in terms of y, the first order forward finite difference, or first forward finite difference, is written like this. And for example, we can write it. For example, if we write, let's say, delta 1 y1, that will mean y2 minus y1. Okay, and if we write it what do you say, delta 1 y2, that will mean y3 minus y2. Okay, and so on and so on, right? This is about what do you say, first forward finite difference or first order forward finite difference. Similarly, what you say, we can go for the second forward finite difference. What is the second order or second forward finite difference? Second forward finite difference. Okay, and it is written as what do you say, delta 2 f of xi. Okay, so this delta 2 can be broken down into two pieces, that is delta 1 into delta 1 of f of xi. Okay, so this will be what do you say, delta 1, and the delta inside the bracket will operate upon f of xi, and you will get f of xi plus delta x and minus f of xi. Okay, now this delta will further operate upon each one inside the bracket, so you will write it delta 1 f of xi plus delta x minus delta 1 f of xi. Okay, now this delta 1 f of xi plus delta x will produce its own results, and delta 1 f of xi will produce its own results. This one, delta 1 f of xi plus delta x, according to the definition of forward finite difference of first order, this will produce this one. This will produce here f of xi plus 2 delta x. Means there is already xi plus delta x. So one more delta x will be added up. So this will become function of xi plus 2 delta x. Okay, minus the value, the original value here before operating this delta. So this is f of xi plus delta x. Okay, and minus this the value of this delta can be obtained from here. This is what you say, f of xi plus delta x, and due to negative sign this will become plus f of xi. Okay, and the result will be what you say, this is f of xi plus 2 delta x. Okay, and this minus f of xi plus delta x and minus f of xi plus delta x will be added up, and we will get here 2f of xi plus delta x and plus f of xi. Okay, so this will be the value, this will be the result of second forward finite difference operating upon f of xi. So this is the effect of the second order or the second FFD upon f of xi will be this one, means the result will be this one, this much. Okay, so in terms of y, okay, or in terms of y, you can write as delta 2 yi can be written as what you say, yi plus 2 minus 2 yi plus 1 plus yi. Okay, where yi plus 2 is actually equivalent to f of xi plus 2 delta x. Okay, and yi plus 1 is just equivalent to f of xi plus delta x. And you already know yi is just f of xi. Okay, okay, so this is the effect of delta 2 yi, and generally of nth order of generally for nth FFD, for nth FFD, FFD stands for forward finite difference. Okay, so in this case delta n f of xi can be written as delta n minus 1, and inside will be delta of f of xi. This which produces delta n minus 1, and inside we will be having f of xi plus delta x and minus f of xi. Okay, or in terms of y, delta n yi can be written as delta n minus 1 and yi plus 1 minus yi. This can be written as delta n minus 1 yi plus 1 minus delta n minus 1 yi. Okay, so for any level of FFD, the result of let's say nth FFD forward finite difference being operated upon the value of the function will produce the result like this. Okay, now these all means different levels of forward finite differences can be written in form of a table, and the table provides you can say readily available information about different forward finite differences, zeroth order, zeroth forward finite difference, first forward finite difference, second forward finite difference. So different forward finite differences of different levels, they can be readily obtained from a table which is called as FFD table, or the table of forward finite differences, and that table can be written like this. Look at. So cat for if we have the data values, we will write above as FFD table. Okay, and in order to write this table, first of all, we must have the values of x and the values of y, and values of y means the values of the function of xi. We have these values. Let's say that means the values of x are x0, x1, x2, x3, and x4. Okay, here I is 0 means index is 0, I is 1, I is 2, I is 3, and I is 4. Okay, these are the index values for the values of x, and over here the values of y corresponding to these values of x are y0, y1, y2, y3, and y4. Okay, so by the way, these values of y are called as zeroth forward finite difference. Okay, this can also be written like this: zeroth FFT, zeroth forward finite difference. Zeroth means the value of the function itself is called zeroth. FFD means the value of x will not change. So that's why the value of the function at the values of x are directly called as zeroth FFT. Okay, means this y0 is actually delta 0 of f of x0. Okay, and this is delta 0 f of x1, and this is delta 0 f of x2, and this is delta 0 f of x3, and this one is delta 0 f of x4. Okay, now for the second FFT, second order FFT, we write it like this, or we write it delta 2 yi. Okay, delta 1 yi. Okay, so the first, this is the, what do you say, first order forward finite difference. That means the first forward difference from the table can be written as y1 minus y0, and that will be, what you say, that will be written as delta 1 y0. Means when you are using when you are finding the value of first FFD at starting with y0, that will be y1 minus y0, and the answer will be written in between them. And over here, this will be, what you say, y1 minus y0. and this is delta 1 y1 in between y1 and y2, and this will be written as y2 minus y1, and over here this will be delta 1 of y2, this will be y3 minus y2, and over here this will be delta 1 of y3, and this will be written as y4 minus y3. And after that we cannot write down, we cannot get the value of delta 1 y4 because for that purpose we need y5, and y5 is not here, that is missing. So we can write only these first forward finite differences, 1 2 3, these four first forward finite differences can be written for these, what do you say, uh, values, 5 values, 1 2 3 4 5. Now for the second, what do you say, I will be directly writing here delta 2 yi. Okay, and that means in this column this will be actually delta 2 y0, and that will be written like this, that is delta 1 y1 minus delta 1 y0. Okay, delta 1 y1 minus delta 1 y0 means second forward finite difference will be actually the difference of two first forward finite differences. That means this delta 1 y1 minus delta 1 y0, and now here this what is it, delta 2 y1 will be written as delta 1 y1 minus delta delta 1 y2 and delta 1 y1. Okay, this one delta 1 y2 minus delta 1 y1. Okay, over here we can write third, what do you say, second FFD, that is delta 2 y2, and that will be actually delta 1 y3 and minus delta 1 y2. Okay, now for the third level, what do you say, the delta 3 y I, and this is further written as delta 2 f of xi, and this is what we say, delta 3 f of xi. Okay, so in this column the third level forward finite differences can be written by using the values of the forward finite differences in the previous column, that is delta 2 y1 minus delta 2 y0, and that is written as delta 3 y0 is equal to delta 2 y1 minus delta 2 y0, and over here delta 3 y1 is written as delta 2 y2 minus delta 2 y1. Okay, now for the last one, that is the fourth order or the fourth forward finite difference is written like this, delta 4 f of xi. Okay, and over here in this column only one what do you say, forward finite difference is possible, that is of fourth level, and that is different of these third order, what do you say, third level forward finite differences, delta 3 y1 minus delta 3 y0, and that is written like this, delta 4 y0 is equal to delta 3 y1 minus delta 3 y0, and this is the last, what do you say, FFD in this table, and this table is called as the table of forward finite differences. And the advantage of this table is that we can readily, you can say, obtain the value of different level forward finite differences starting from any value of y. Okay, so this table is very useful while, what do you say, going to perform numerical differentiation and numerical integration. It is just like we, what do you say, use the tables of different numbers, the table of 2, table of 3, table of 4, table of 5, and so on. And the purpose of those tables is just to facilitate the process of division and multiplication and addition and so on. So in case of numerical processes, in case of while during the process of numerical integration, numerical differentiation. These tables of finite differences are very useful. Okay, so that's all for this topic. Thank you.